Hi students, welcome to chemistry online classes. Last class I discussed about some preparation of carboxylic acid. Now, one more preparation, that is from, I think this is the fifth one, from acyl halide ion anhydrides. Okay. What is the acyl halides? RC double bond OX. This X may be Cl, Br, This X may be Cl, Br. Generally, we are using this chlorine only in the many equations. Next, anhydrous being R, CO, twice O. Actually, how it is represented? RC double bond. How many times is it RC double bond? 2 times. Then C double bond O R. In between this is O. This extra O. This is anhydride. How it is formed we will discuss in its property, carboxylic acid properties. There we will discuss. So this is acid halide. This is anhydride. From this we are going to prepare the carboxylic acid. Carefully observe here, RC double bond OCl. This acyl halide, here it is also known as the acyl chloride, or it is known as the acid chloride. Okay, what you call this is acid chloride, acyl chloride. Chlorine is the chloride, halide is the halide. Okay. This is on hydrolysis. H3O plus. Otherwise H2 only take, no problem here. H2O. On hydrolysis. Already I given one trick also how to write the hydrolysis steps. How to write? Here carbon, here chlorine. Clear this is? This is which one? Chlorine is more electronegative. Carbon is less electronegative. Then water molecule we know that OH and H. Why I got H here, why not here? Because less electronegative bond with the more electronegative bond with the less electronegative. Then we will get here RC double bond OH and this is H. Then this is carboxylic acid form here. Somewhat this is slow reaction because again it may undergo backward also. Then in presence of base, generally we take this reaction, this general reaction. One example we will take now. But one example means CH3, C double bond O, Cl, hydrolysis. This hydrolysis reaction with water. Then we will get here. I am not writing now this breaking bond. You know that how it is break down. C double bond O, OH and HCl. Okay. If you want, this called acetyl chloride. Acetyl chloride. This is C double bond OCl. This is called benzoyl. Already somewhere I explained that what is benzyl, what is benzoyl. So this benzoyl, not benzyl. Benzyl means what is after benzene, one CH2. So this is benzoyl chloride. Okay, this benzyl chloride again here react with the water. Then we will get this is C double bond OH and this is H. Like this, any reaction we can write to prepare what the respective carboxylic acid. This is acetic acid. This is benzoic acid. This is from acyl halide. Next we take the anhydride. But this reaction also we can carry it out in presence of base. Here only just water is there. This reaction somewhat slow. To speed up this reaction we can use in basic medium also. Now I am taking this general reaction RC double bond OCl in presence of base OH minus. Okay, in presence of base hydrolysis. Carefully observe. Already I told you somewhere in the last reaction also. In basic meaning it forms first carboxylate. Later if you use the hydrolysis acid acid work out, then it converted to carboxylic acid. Carefully observe. Now, this OH minus attack against Cl minus eliminate. Then what you will get here? C double bond O, H and Cl minus. But here water oxide, this proton will takes here and it converted to carboxylate form only, and it is negative. If you do here hydrolysis step, acid hydrolysis, then it converts into RC double bond OH. First it forms the carboxylate, later it converts into carboxylic acid. This why we are using the OH mechanism to speed up the reaction. Otherwise, normal you can use, no problem here. Now this is acid halide. Now anhydride. Take one anhydride. Now I am taking one anhydride that is called acidic anhydride. CH3 C double bond OH. This is acetic acid. This is acetic acid. For your understanding purpose, I am writing this actually how the acidic anhydride is formed. This is what is another acetic acid. Now water molecule loss. Water molecule loss. CH3 C double bond O, like R C double bond O. Then one O is there. Next C double bond O R. Then like this, what we will get? Anhydride will get. Now we know that how the anhydride is formed. Anhydride is what is the loss of water molecule. The water molecule not present. That is called anhydride. Hydrate means water present. Anhydride means there is no water. So now I am taking here CH3 C double bond O CH double bond O CH. This is called acetic acid respect to anhydride form. Therefore it is called acidic anhydride. Okay, acetic anhydride this is. Then here water hydrolysis. Observe carefully here. You can break this bond left side or right side. Which side you want you can break, because both are equivalent here. Then if you break down this side, you know that this is less electronegative, this is more electronegative. More electronegative with the less electronegative part, less electronegative with the more electronegative part. Then I am writing here now product here CH3 C double bond O. Less electronegative carbon, then what will you get? OH or H? OH. Then this is OH. Now CH3 C double bond O. Then we will get H. Then again it converts the same amount of things, then we get 2 moles. Okay. This is called acetic acid. Okay. Now you can take now benzene. Here acetyl chloride taken. Next benzoic chloride. Acetic anhydride. Next benzoic anhydride. So now I am taking here benzoic anhydride. What is the benzoic anhydride formula? Carefully observe here. Both sides is acetyl group is there. Here also what you have to write? Both sides benzoyl group we have to write. Okay. This part is known as benzoyl. Otherwise you can observe here. I wrote here benzoyl chloride. This is chloride part. This is benzoyl. So it is called benzoic anhydride. Benzoic anhydride. This benzoic anhydride reacts with the water. Then same type of reaction we will get here. Then without writing any mechanism, that directly I will write here what is formed. Benzoic acid form. You know that how to write this. How many moles form? 2 moles. This is called benzoic acid. Next. Now you can take here. Now I am writing both sides not same. One side is benzoic, another side is CH3. See. Here both sides same group is there. CH3CO, CH3CO. That's what is called same compound molecule, lost water molecule, and it forms the acetic anhydride. Here benzoic acid, lost water molecule, then form benzoic anhydride. Here benzoic acid and acetic acid both combine to form one water molecule. Like this called. What is the name now? This benzoic, this is acetic. Then it is called. Actually, it is called according to alphabetical order. Organic chemistry. It means IUPAC name is these two carbons ethanoic. This is benzoic when we call here. Then A, B, C, D alphabetical order. B first or E first, B only. That's why benzoic, ethanoic, anhydride. What is the name? Benzoic, ethanoic, anhydride. Actually, you know the IUPAC name how to write, but somewhat complicated will come in the whatever the function we are not frequently used. This anhydride function not frequently used. Only which one you are using? Aldehyde, carboxylic acid, alcohol, ethers like this only. But these are rarely will come in competitive exam purpose. Like this question will give write the IUPAC name or what is the IUPAC name? Like this question will come. So somewhat you have to concentrate for neat level IUPAC names of this other functional. Now you can take here H2O. Anyway, here we got 2 moles. Here we will not get the 2 moles. We will get 1 mole benzoic acid, 1 mole acetic acid. Then 1 mole of benzoic acid, 1 mole of acetic acid. You know names, that's why I am not writing them. Already given. Benzoic acid is acetic acid. Okay. So this is from acyl halide and anhydride. Next, another one will be the 6th preparation method. I think this is last according to our textbook. So many methods can be there, but according to our textbook only I am writing here. This is from esters. From esters. Ester formula we know. What is ester? RC double bond OR. This is ester. This ester on hydrolysis RC double bond O. First I am writing the general reaction. It may be same or it may be different. Alkyl group may be same. Here CH3 is in, here also CH3. Or here CH3 is in, here ethyl group may be there. Whatever it may be same or different, that is your choice. Whatever you may take, no problem here. Now, here acetic hydrolysis also is there, basic hydrolysis also is there. Now this is which one? S plus is there, H plus it is. Generally it is carefully observed. H plus, it can be represented in this form also. H3O plus. You learn in equilibrium chapter or any equilibrium chapter in first year. H plus will not exist as an H plus independently. Always it is in this form. So in textbook or in any reference book, H plus are generally written in this form. Okay? Then also you have to consider this is what you call acidic medium. Okay? Acid hydrolysis. H plus and water both combine to form which one? H3O plus. So acid hydrolysis reaction this is. Then we will get here RC double bond O. RC double bond. Hydrolysis step we know that if you have breakdown, then this carbon is less electronegative. This is more electronegative. More electronegative then we will get H. Less electronegative in here R dash. This is got H mean. This is will get which one? OH. Then we will get here OH alcohol. Okay. One general example I will take here CH3 C double bond O CH3. Now R dash is taken as the same. Then now acetic hydrolysis CH3CO H2O plus. Now break down here. Then we will get CH3 double bond O and H and here CH3. Okay. So one H. Okay. But this is just our understanding purpose how to write the product on. But sometimes if they may give the labeling means oxygen having which one? O16, O18. Okay, these are the isotopes. If they mention here O18, then this O18 goes along with this carbon or along with this carbon? That is also the question. Then when we will know this, it goes along with the carbon, along with this carbon, if you know the mechanism. If you don't know mechanism, you can't tell here, but I will give. When this ester is formed, see, CH3C double bond OH and HO CH3. This is ester formation. When ester form in alpha chapter we studied that here OH bond only break and this is COH bond break. Here, this is a condition. Here this OH and here is not formed. Here H and here OH will not lost as a water molecule. This is already studied in the alcohol chapter. Okay. Next, in properties also is there esterification again in this chapter. There also will discuss. So this is combined from this one CH3, C double bond O, this O and C. If it is O18, then here also what will you get here? O18. If it is O18, then in loss of water molecule there will get O18. So already we know that this O goes along with which one? Methyl alcohol. That is also we have to learn for competitive exam. But now this is only theory part, doesn't a little bit not answering that part. When it comes in the competitive part, again detail I will discuss. Okay. So this is about the acidic hydrolysis. In acidic hydrolysis, keep in mind here OH will come. In basic hydrolysis, what will you get here? O minus. That is carboxylic will get. Okay. So now I am writing the basic hydrolysis. Now I am taking same CH3, C double bond O, CH3 in basic hydrolysis, OH minus and water. Then first we will get here CH3, C double bond O minus and this will be ethyl alcohol, methyl alcohol. This later on acidic workup, then this will be converted into CH3, C double bond OH, acidic acid. So this we have carefully observed because in textbook all the sentence very clearly explained, but we will not that much concentrate because we don't know how in examination they will ask. But already we experience how they are asking the question. So I am stressing each and every word where you have to concentrate for competitive work. PUC board just equation, one equation enough. How to write in PUC board? Ester on acidic hydrolysis, it gives a carboxylic acid in alcohol. Enough. One general reaction if you want one specific example. Competitive part what they will ask? Same equation they will give. What is the product forming acidic medium? Option A, B, C, D. Like say from the textbook. Okay. So with this all preparation part. Now we can take. Now I explain with the aliphatic. Aromatic also can take here. Aromatic one benefit on this C double bond O. Here you can take always I to be here methyl. Now we can take ethyl also. Ethyl it is represented as C2H5. Now you want which one? Acidic hydrolysis or basic hydrolysis? Anyone your choice. So if you want the acidic hydrolysis, then I want that H3O plus. Then one we will get here benzoic acid plus another is C2H5OH. But this reaction is generally reversible reaction. Then it may be given like this also. This is generally reversible reaction. Because in ester formation already I explained that is in alcohol chapter. This is esterification reaction generally reversible reaction. Here also somewhat reversibility is there. That's why I told you somewhat slow reaction. Here also compulsory reversibility is there. Because someday we will forget this reversible reaction. Some lectures may consider that one, they will not use the marks also in these. Each and every word write carefully from the textbook. When you are going to writing for only PUC exam, follow the textbook. Competitive exam purpose, follow the what we are teaching the lecture, your notes or any other objective. PUC exam is there. What is exactly present in the textbook? Why I am repeating this word means some lectures may be experienced, some lectures may be not that much experienced. What they will say, what is present in the textbook. So that because in class we will explain in other form. That lecture may you don't know. Then what happen here? You will get the lesson. So follow the textbook for PhD. In sometime you are following some publication book. In that some print mistake may be. That's why you follow only textbook. Next, this is all preparation methods. After this preparation method, we will go for the properties. Okay. In properties, first one, physical properties. Physical properties. Now, according to this physical property, what we will discuss first? Physical state. Next is boiling point, solubility. In every chapter, these are only we are discussing. From halogen to alcohol, phenol, ether, aldehyde, ketone, carboxylic acid, next amino acid. Keep in mind, what are the physical properties we will discuss? First one is physical state. Next, boiling point or melting point. Next, solubility. These are the three. Sometimes density also is there according to that which chapter is required. Okay, but mainly these are the three: physical state, boiling point or melting point. Next is solubility. So now, first physical property we are discussing here: C1 to C9 carbon carboxylic acid. C1 carbon means what is that? Formic acid. Formic acid having how many carbon? One. And acetic acid having how many carbon? Two. Already shown here acetic acid, 2 carbons. So this is C9, what is that? Nonoic acid. It means 9 carbon acid it is. So up to 9 carbon, they are colorless liquid. After that, it means from C10 onwards, from C10 to higher. C10 to higher carboxylic acids or wax-like solids. Okay, but keep in mind, C1 to C9 colorless liquids are having unpleasant smell, unpleasant odor. Order of, instead of using smell, you have to use order. Okay, but C10 to higher carboxylic acid do not have any smells. They are normal. These are somewhat volatile nature. Which is volatile is there that having a smell. Which is solid is there. Solid do not have that much smell. You can observe now. Perfume is there. That is what you got in the form of vapor. That is easily can spread and it gives a smell. If any solid part is there, solid parts are having somewhat less. Okay. So these are having unpleasant odor. If you go to the laboratory, then you will get these type of acetic acid present, formic acid will be present in the laboratory. If you open the cap of that bottle, you will get somewhat irritated. These are called unpleasant odor. But wax like these are having somewhat not that much. You may be seen also waxes. Okay, for sealing purpose or somebody we are using that to seal the cap or somewhere this wax board you heard. Otherwise, when you learn in the biology also some wax will produce the bees or something that is not having smell that much. Okay, so these are the wax-like solids. Next one, boiling point. Some other maybe is there, but these are important ones here. Boiling point. So now, higher boiling point compounds in organic is generally carboxylic acid. Next, alcohols, carboxylic acids, alcohols. Next, ketones. Next, aldehydes. Remaining. Why I am using this one? All are having the carbonyl compound. It means C double bond group present here. Here also C double bond group, here also C double bond group present. But this is having OH, this is also having OH. That purpose, these compounds I discussed here. Remaining all we can discuss in alkane, alkyne, benzene, ethers, halogen, all we can discuss. But that much is not required here. So these are the close hydrogen bonding content compounds and having near molecular mass and near dipole moment also. That's purpose I am discussing these compounds. Now, this having the why it is having more boiling point reason here? Reason I am writing here because of intermolecular hydrogen bond. Here also intermolecular hydrogen bond is present in alcohol. Then you may ask the question, then why this is only having the more boiling point, why this is having the less boiling point? We will discuss that. Don't worry. Ketones do not having the hydrogen bond. Aldehydes also do not having the hydrogen bond. But don't confuse. All these can form hydrogen bond with the water. That is not a consideration here. Themselves, ketone do not form. Aldehyde do not form hydrogen bond. Okay? So that hydrogen bond I am discussing here. Sir, you told that these are also from hydrogen bond. What with water they can form? That time we are not discussing boiling. That time we discuss which one? Solubility. Now itself do not form hydrogen bond. That is the condition. Okay? Here no hydrogen bond. No. Here hydrogen bond is present. Here hydrogen bond is present. But here which type of hydrogen bond present? Extensive. Extensively hydrogen. It means like this. If you want that, I will show here. CH3, C double bond OH, OH, C double bond CH. One example I am taking here, acetic acid. Then in between this here hydrogen bond form. Here in between this is hydrogen bond. How many hydrogen bond it form? If you take the alcohol, ROH, HOR. Here how many hydrogen bonds present? 1. When number of bond increases, to break that energy also required more. That's why it is having a more boiling point, it is having a less boiling. Here no boiling hydrogen bond present. These are polar. Only dipole force is there. So already I told you that how to check the boiling point. First to check the van der Waals, next molecular weight, next go for van der Waals force, next go for dipole force. Okay, next go for the hydrogen bond. So in that, which is major part, all forces are present. That having more boiling point. That I will write here. How to check? Molecular weight check. Next, London force or induced force, that is London force. Next, which one? Dipole force, dipole force. Next, which one? Hydrogen bond. Ion hydrogen bond also we can, but generally ion hydrogen bond, ion dipole force are very rare in this compound, so that I am omitting here. But somewhere I explain that. Molecular weight check. Higher molecular weight is higher boiling point. Lower molecular weight, lower boiling point. If all are having a near molecular weight, even 1-2 difference is there, or up to 4-5 units difference is there. One having a 55, another having a 60. Only small difference is there. 5 up to 5 you can consider here. One having the 55, another having the 80, it's lot difference. That is higher only the having the higher boiling point, lower having the lower boiling point. But 1-2 units difference or 1 up to 4 units are difference is there. That remaining also consideration we have to take here. Okay. London force generally all molecule have it, so this is present in all. Dipole force, it means depends upon the polarity. Hydrogen bond like is already explained here. So in this, what is present? Molecular weight we have to check how much, nearly 60 some is there. If you check this acetic acid having 60 molecular weight. If you take any other alcohol, that respect you can take molecular weight. London force and dipole hydrogen bond all are present here. But if you take alcohol, here also which is present? All are present. But all are present in here, which is predominant here, hydrogen bond more than the alcohol. Here 2 other, here 1 is there. If you consider here, which one is London force present, dipole force present, but hydrogen bond not present. Here also hydrogen bond not present. But here both are having the same type. London force present, dipole force present. Then why it is only the more boiling point, why it is less boiling point? Its dipole nature is more. Its polarity is more. More polar, more boiling point. So all this consideration we have to practice. View purpose.